Okay, we are Team B11. We did the beam project. I'm Will Rabin,
I'm Hank Rudolph.
And I'm Evan Robinson.
aka Dream Team.
For the beam project, we had to test 4 different parameters to evaluate the stiffness of certain beams. Those 4 parameters were E, elasticity, W, width, T, thickness, and L, length. And with each of those parameters, there's an exponent that we had to find separately for each case. And also for each case, we had to calculate C, which is the constant. The second equation you see is point load is equal to stiffness times deflection. In this graph, we graph point load versus deflection in meters. And as you can see, we tested different lengths and got different line slopes. The slopes of the lines is K, the stiffness. We calculate the average stiffness and graphed it versus each deflection in meters. And as you can see, as the length of a beam increases, its stiffness exponentially decreases.
Okay, for each parameter we had an exponent, like Evan said, and we had to calculate the value of that exponent. In this table, we give you the values, and we also had to calculate the value of the constant, and we found that to be 0.25 and unitless.
For the third part of the experiment, we needed to determine what type of beam and what the dimensions of the cross-section were that would allow instruments to be put on it that had an estimated drag force. And the beam we got was a stainless steel beam. And for stainless steel that we used in the first part of the project, we used our data analysis and predicted a value of deflection given a mass value, and our analysis was pretty solid because the error was fairly small.
Okay, for a beam recommendation, we recommend stainless steel as the best material for the beam because it's very rust resistant, it's very durable, more durable than aluminum. Stainless steel also has a higher elasticity than aluminum, which in turn produces a greater beam stiffness. The best cross-section to use for stainless steel was 0.25 by 0.25 inches. We found that these configurations are very cost-effective, and we believe that stainless steel is the best recommendation for the beam material.